turbine. The steam is passed into the condenser where it is condensed back, and this condensed water is once again pumped back into the reactor. So, if you observe, water here is used both as a coolant as well as a moderator. In this type of boiling water reactor plant, we employ enriched uranium as the fuel. That uranium is subjected to nuclear reactions, because of which heat is generated. The heat is carried away by the water and it is getting converted into steam. The steam is sent through the turbines. We have got the control rods which can be moved in and out of the reactor core, which absorbs the neutrons that are present in the reactor core, is not it? This we have already seen. The control rod's main property is to absorb the reactions that are taking place. That is, it will absorb the neutrons and thereby control the reactions that are taking place inside the nuclear reactor. Okay. Now, let us talk about the next type of reactor. The next type of reactor that we have are, or let us look at the points pertaining to boiling water reactor plant. Enriched uranium is used as fuel. Water is used as both moderator as well as coolant. Steam is generated in the reactor itself. That is, as we have seen, the water flows through the reactor core, takes away the heat that is generated and gets converted into steam. Steam passes through the turbine to generator in order to generate the electrical energy. Now, let us talk about the next type of reactor that we have. That is, the next type of reactor that we are going to talk is a pressurized water reactor plant. The name itself is indicating pressurized water reactor. The water is sent through the reactor at a very high pressures. So, when the water is flowing through the reactor, if you observe the slide, I got the reactor, the water is flowing through the reactor core at a very high pressures. So, the water carries the heat that is generated in the reactor core and it flows through the heat exchanger. In the heat exchanger, the heat is transferred from this water to the water gets converted into steam and it flows through the turbine and back to the heat exchanger. This process continues. Now, we might be getting a doubt, the water is flowing, so does not the water gets converted to steam? No, the water does not get converted to steam, because the pressure at which the water is sent through the reactor core is very high. So, the water is not allowed to boil, is not it? The water it carries away the heat and it passes and goes into the heat exchanger. So, not enough time is given for the water to get converted into steam. So, the process it continues. That is why we are saying it is a pressurized water reactor plant. The water it carries, this flows through and it gives away the heat in the heat exchanger to the water gets converted into steam, flows through the turbine to the condenser back to heat exchanger, as well as the mechanical energy that is generated is given to the generator, which converts the mechanical energy into electrical energy. Here also, in this case, in the pressurized water reactor, enriched uranium is used as the fuel as well as the water, it acts as moderator, coolant as well as reflector. This is about the pressurized water reactor plant. Now, if we observe, if we compare the boiling water reactor as well as the pressurized water reactor plant, in boiling water reactor, the water is converted to steam in the reactor itself, whereas here the steam is generated in the heat exchanger, isn't it? The water, it is at high pressure, it is collecting the heat, flowing through the heat exchanger. In the heat exchanger, the water, it picks up the heat and it gets converted to steam. So, the steam is generated in a heat exchanger. As we have said earlier, the steam is generated in the heat exchanger. It is similar to that of a boiler in a thermal power plant. Let us look at some points of pressurized water reactor plant. That is, enriched uranium is used as fuel. Water under pressure is used as both moderator and coolant. Steam is generated in heat exchanger. As said, the water flows through reactor, takes away the heat, flows through heat exchanger. The water, it flows through the heat exchanger, takes the heat as well as gets converted into steam. Now, let us talk about the next type of reactor that we have. Next type of reactor that we are going to talk is a fast breeder reactor. In fast breeder reactor, we have got two heat exchangers. If we observe, the uranium core is covered with U-238. This is the entire reactor plant, and we have got intermediate heat exchanger. We have the steam generator. Here we have two metal circuits. We are employing liquid sodium as a primary coolant. We are applying liquid sodium potash as secondary coolant. If we observe, the sodium, it flows through the reactor, picks up the heat and flows into the intermediate heat exchanger. In the intermediate heat exchanger, we have got another circuit where a liquid sodium potash, it passes through the intermediate heat exchanger, takes away the heat and passes through the steam generator. In the steam generator, the water is getting converted into steam, and the steam, it flows through the turbine and flows through the condenser and back to the steam generator. This type of a reactor is called as a breeder reactor, because the neutrons are absorbed by U-238, which gets converted into thorium, into plutonium, which is used for the various purposes, right. So, here we are breeding another nuclear fuel, isn't it? That is why it is called as a breeder reactor plant. The primary coolant takes away the heat, flows through the heat exchanger. The secondary coolant takes